Question number 5 and 6 of 6.4. You are given a triangle ABC, D, E, and F are the midpoints. We have to find the ratio of the area of DEF, that is the triangle that is formed in between, and the bigger triangle ABC. Okay, so D and F are midpoints. Now, using the midpoint theorem, which you have done in class 9, we know that the line joining midpoints will be parallel and half of the third side. So, by that property, we can say DF is half of BC. Similarly, EF will be half of AB and DE will be half of AC. So all the sides of the small triangle are actually half of the bigger triangle. And therefore we can say this small triangle and bigger triangle are similar by SSS because the ratio of the sides is 1:2. Right? So one of the conditions of similarity is that if the sides of the two triangles are in the ratio, a particular ratio, then they are similar. So all the sides of the small triangle is actually half of the bigger. So ratio of sides is 1:2. So triangles are similar. And once the triangles are proved similar, then we can use the theorem that ratio of areas of two similar triangles is square of their corresponding sides. So area of DEF by area of ACB will be equal to DF square, or we can say any side. Here I have taken DE square upon AC square. We can take DF square by BC square or EF square by AB square, any one of the corresponding sides. So in this example, here I have taken DE square by AC square. And we know by midpoint theorem that DE is half of AC. So we get half AC whole square by AC square. Open the bracket, we get 1/4 AC square by AC square. AC square gets cancelled, and therefore we can say the required ratio obtained is 1:4. Right? 1/4 means 1:4. So final answer we'll say ratio of area of DEF by ACB is 1:4. Then question number 6. You are given two triangles ABC and triangle PQR. They are already given similar to each other, and it's already given that AD and PM are the medians. Now if you remember what are medians, medians are line drawn from the vertex to the midpoint of the opposite side. So this is a midpoint here. What we need to prove here is that ratio of areas of the two triangles ABC and DEF is equal to the square of their corresponding medians, that is AD square by PM square. So we are going to start in the traditional method by using the formula area of triangle is half base into height. So area of ABC will be half BC into AD, and area of triangle PQR will be half QR into PM. Okay, this should be PQR. This is PQR. So area of PQR will be half QR into PM. Half is getting cancelled, so we are left with BC by QR into AD by PM. Then the next part, we are taking the triangle ABC and PQM. We are taking the triangles and proving them similar. So AB by PQ is equal to BC by QR. That is already derived because the bigger two triangles are similar. So corresponding sides are in proportion. So AB by PQ is equal to BC by QR. Now instead of BC I can write 2BD, and instead of QR I can write 2QM, because AD and PM are the midpoints, so these are actually midpoints. AD and PM are the medians, so D and M are the midpoints. So BC can be replaced with 2BD and QR is replaced with 2QM. 2 is getting cancelled. So what do we get? AB by PQ is equal to BD by QM. And angle B and Q are equal because the bigger triangles are, as it is given, similar. So these two small triangles ABD and PQM are similar by SAS because we have proved two sides in proportion and one angle equal, right? So the smaller triangles ABD and PQM are going to be similar by SAS. Now once the triangles are proved similar, then we can say that AB by PQ is the same as AD by PM. AB by PQ is the same as AD by PM, because if the small two triangles are similar, the corresponding parts of the similar triangles are in proportion, right? Now AB by PQ is equal to BC by QR. AB by PQ is equal to BC by QR because the bigger triangles are already given similar. So the corresponding parts of similar triangles are in proportion. And if you look at these two now, AB by PQ is equal to AD by PM and AB by PQ equal to BC by QR. AB by PQ is common, so conclusion we can say that AD by PM is the same as BC by QR. AD by PM is the same as BC by QR. So therefore we can substitute this equation 2 in equation 1, and therefore what do we get? Area of ABC by area of DEF is equal to, instead of BC by QR, replace it with AD by PM into AD by PM. So we get the required result AD square by PM square.